Hello students, welcome to AIMS India online classes. This is a chemistry session. Here we are discussing about the chapter Is Matter Pure? From this chapter, in this session we are going to see different separation techniques used to separate the components of mixtures. Many of the material around us are mixtures. These mixtures have two or more than two constituents mixed in them, isn't it? We see so many kinds of mixtures around us. So those substances are made up of two or more than two kinds of constituents in them. It may not be possible to use a mixture as such in homes and in industries. Yes, those materials directly they may not be used. So the components in that should be separated. So we may require only one or two separate constituents of a mixture for our use. So we have to separate the various mixtures into their individual constituents to make them useful in our daily life. The various constituents of a mixture have different physical properties such as density, solubility, size, particles volatility, boiling point, and etc. So the constituent of mixture may have these properties different from one to another. Based upon these properties, the components or constituents of a mixture can be separated by using different methods. Here, one point is erosion, that is volatility. Do you have an idea about this volatility? Volatility means the property of a liquid substance by which it can be converted into gaseous form below its boiling point, or it can be evaporated below its boiling point. That property is called volatility, and that liquid is called volatile liquid. For example, if you say water, actually the boiling point of water is 100 degrees Celsius as we know. But we know water will be evaporated at the normal temperatures also. Need not to heat water till 100 degrees Celsius. If we take some one glass of water, we pour on the floor. If we observe after a few minutes or hours, there will be no water on the floor. Where will it be gone? It will be evaporated. Even though without heating that water, that evaporates. Without coming to its boiling point, water will be evaporated. Such property by which liquids evaporate below their boiling point is called volatility, and those liquids are called volatile liquids. Okay, this volatility also will be different for different kinds of liquids. So based upon the difference in these physical properties, components can be separated. Heterogeneous mixtures can be separated into their respective components by simple physical methods such as hand picking, sieving, filtration, etc. in our daily life, isn't it? Yes. Heterogeneous mixtures they contain components which can be seen their components separately. For example, if you take rice with some stones, those that comes under heterogeneous mixture because those stones will be seen clearly with a different color and different size. So they can be separated by using some hand picking method. Okay. Next, however, for separating homogeneous mixtures, special techniques are employed depending upon the difference in one or more physical properties. Yes, actually, the separation of heterogeneous mixtures is somewhat easier when compared to separation of homogeneous mixtures because in heterogeneous mixtures there will be difference in their appearance or texture or size. Some one of the physical properties will be varied and it can be observed very easily so that they can be separated by using simple techniques like hand picking, sieving, filtration, by these all. But the separation of homogeneous mixtures is needs a little work because in homogeneous mixtures the components cannot be seen clearly one another separate, isn't it? So first let us see some homogeneous mixtures how they are separated. One of those is one category is solid mixtures. Now here let us see the separation of solid mixtures. One of the examples, solvent extraction. So this is one of the technique used for separation of solid mixtures. In this method of separation, solubility of one of the components in a solvent is used. For example, a mixture of sulfur and sand can be separated by this method. See here, the solid components are sulfur and sand. Actually, these two are insoluble into water, and these when they are mixed, almost the particle size will be same. These cannot be separated by using either filtration and dissolve. So for this kind of mixtures, we have to use solvent extraction. In this method, one of the solid substance will be dissolved in the solvent in which they are made to dissolve. But one will be undissolved, it will be settled down. So that can be separated. For example, they have given the mixture here, sulfur and sand. Out of these two solid substances, sulfur is soluble into carbon disulfide liquid. It is one of the organic substance. It is a liquid. Into this carbon disulfide, sulfur dissolves. So when you add this mixture of sulfur and sand into this carbon disulfide liquid, then what happens? Sulfur will be dissolved and sand settles down like this. Now, if you filter this, what happens? The mixture of carbon disulfide and sulfur will be separated in the form of filtrate, and in the filter paper, sand will be remained as residue. So, sand can be separated in that way. After that, sulfur can be separated from this carbon disulfide by the evaporation technique or some other distillation method. Okay, in this way, two solids, the mixture of two solid components can be separated by using solvent extraction method. In this method, one of the two solid materials will be dissolved into one of the solvents taken there. So when these two are dissolved into solvent, a liquid solvent, one of these two solids will be dissolved, other one will be remained in the solid form. That can be separated easily by filtration. Okay, here carbon disulfide dissolves sulfur. So in this way, by using solvent extraction, sand can be separated from sulfur. Next technique, magnetic separation. In this method of separation, magnetic property of one of the components is used. For example, mixture of iron ore and sand can be separated by this method. We know here iron ore is a substance which is attracted by magnet. So when you take the mixture of a magnetic ore or magnetic substance with the sand, if you so these are the machineries which are used to separate these magnetic particles and non-magnetic sand particles. So if they take here the mixture of these two, they pour on this belt. This belt is attached to two wheels. This will be attached to motor, and this wheel is made up of magnetic wheel. On this there is a belt connection. Now when this ore is poured on this, as this belt is moving, slowly the ore will be moving towards this magnetic wheel. Well, in these two, one is a magnetic component, other one is a non-magnetic sand particles. So when this wheel is rotating, these non-magnetic sand particles directly they fall here and they form a small heap here. Whereas magnetic ore particles, they stick to the magnet for certain time. After a certain time, they leave the magnet wheel and they fall separately as a separate heap. In this way, magnetic particles, non-magnetic sand particles can be separated by using magnetic separation technique. Okay, this generally this in the large quantities to separate the ores in the large quantities. Next technique, gravity method. In this method of separation, difference in densities of components is used. For example, mixture of sand and a chalk powder can be separated by this method. Here, sand being heavier than chalk powder sinks in water, whereas chalk powder floats on water. Actually, it will be floating in the water, chalk powder, as it is being lighter in weight. Immediately after stirring, immediately sand settles down. Chalk powder will be still dissolved in the water, spreading in the water. So that can be separated by using decantation process. So sand will be remain down. Generally, in the ores also, they separate some lightweight particles from the metallic ores by this gravity method also. So what they are doing here, they take some water flow and they make this water in the high speed on a platform with the wedges, ups and downs. So into this water flow, they pour this ore. When ore is poured, the heavyweight ore particles will be remained in these wedges, and the lightweight particles, the other impurities, will flow along with this water. So the lightweight particles will go along with the water to other side, whereas heavy particles will be remained in these wedges. As they are heavy, they settle down in these wedges. So in this way, lightweight particles can be separated by this method. This is called gravity method. Okay. Next, separation of solid liquid mixtures. Let us see one of the techniques to separate these solid liquid mixtures is sedimentation, decantation. So two processes are involved in this. One of them is the process in which an impure liquid is allowed to stand undisturbed. Small dust particles get settled down due to S gravitational pull, leaving a clear solution above it. This is called sedimentation. So, what is happening here? If you take an impure liquid in a beaker and if you allow this liquid to stand for some time, what happens then? The heavy particles, heavy dust particles which are there in the water, dust particles, sand particles, whatever impure substance, solid particles are there, they settle down in the beaker or container. Pure liquid will be above those impurities. This method of settling down of solid particles in the liquid when it is allowed to stand for few certain time is called sedimentation. Sedimentation means settling down of these solid particles in a container of liquid and solid mixture. Now those impurities are called sediment and the pure liquid floating on is called supernatant liquid. This separation method is called sedimentation. Now what they do, they slowly separate this pure liquid floating into another container by bending this container very slowly. This separation of the supernatant or pure liquid into another container slowly is called decantation. So here two techniques are involved. Separation of a solid liquid mixtures in this sedimentation decantation process. Two are there. First, they will allow these solid particles in a liquid to settle down. How? By leaving this container without disturbing for few certain time. Then what happens? All the solid particles they will settle down. That is called sedimentation. After settling down, the pure liquid came up will be taken into another container slowly by bending it. That separation of pure liquid floating up is called decantation. So these two are uh, simultaneous processes: sedimentation and decantation. In this, solid will be remain down, which is called sediment, and that pure liquid will be separated into other container by the decantation process. That pure liquid separated is called here supernatant. Okay, it is one of the techniques. For example, if you take sand and water in a beaker, if you stir the water for few seconds, then what happen? Sand particles will spread over in the water. And if you allow this beaker to stand for few minutes, all the sand particles and dust particles will settle down. Pure water will come up. That pure water here it is called supernatant, and those sand and dust particles settle down are called sediment. Now, by taking one more beaker as shown in the figure, if you slowly bend this container and if you allow this pure liquid to come into another container, that is called decantation. Okay, by that pure liquid which is called supernatant is separated into another container. sediment will be remained in the previous container. Okay, this one. Next one, filtration. Filtration is also one of the techniques used for the separation of solid liquid mixtures. In this, the solid component is spreading in the liquid, but it is immiscible or it won't dissolve into that liquid. In that case, this filtration can be used. This method is used for the separation of different sized particles of insoluble solid components present in a solvent. For example, mixture of barium sulfate and water can be separated by filtration method. Here, barium sulfate is one of the chemicals which is insoluble into water. It won't be dissolved. Generally, this barium sulfate will be formed as a precipitate in the chemical reactions. So when you dissolve this barium sulfate, it won't be soluble into water and it settles down. So it you can separate this by filtration process. So in this way, if we take barium sulfate solution or the mixture of barium sulfate and water into a beaker, and if we pour this through a filter paper which is kept in filter funnel, now what happens that pure water will come down, which is called as filtrate, and that barium sulfate, which is insoluble solid substance, will be remained in this filter paper, which is called residue. Now that pure liquid obtained is called filtrate. This technique is called filtration. Okay. For the filtration, generally we take filter papers. Next technique, centrifugation. In this method of separation, difference in size of liquid particles is used. For example, milk contains solid fat particles in water and can be separated by this method. Here, size of solid particles is less and hence they pass through the filter paper. Yes, if we take milk, it contains, as we know, some fat particles. Actually, as these are solid particles, but these cannot be separated by using technique filtration. Why? Because the fat particles are very smaller in size. So this mixture cannot be separated by filtration process. Then to separate these particles, we can use this technique called centrifugation. In the centrifugation process, the fat particles present in the milk also can be separated. When this mixture or this milk is subjected to centrifugation, heavier fat particles will settle down at the bottom of leaving lighter water on the top. So if you take the sample of blood or milk into the test tubes, and if we keep these test tubes into this container called centrifuger, so after closing this, if we switch that on, it rotates with very high speed. On rotating these test tubes with the high speed, the heavy weight particles present in that solution or mixture, suppose if it is milk, those heavyweight fat particles will come to the bottom of the test tube. Remaining liquid part like water will be at the top. In this way, those solid particles can be separated by using this technique called centrifugation. Next, separation of gas-gas mixtures. It is a little difficult process actually because gases they cannot be seen. So different techniques to be used for the separation of these gases. First among them is diffusion. In this method of separation, difference in the densities of component gases is used. The gas with a lower molecular weight diffuses faster than the gas with a higher molecular weight. Okay. In this way, diffusion technique is used for the separation of two gaseous components. So here the difference or the property used for the separation of gases is their densities or molecular weights. The gas with the heavier molecular weight can move a little slower, and the gas with the lighter molecular weight can move faster. So, based upon this technique, gases can be separated in this diffusion process. So if these two gases or the mixture of two gases is allowed to pass through a membrane. Membrane means it is like filter paper, but it is having very micro holes through that. So when you allow this gases mixture through that, the gas which is having lighter weight molecules or small molecules only can pass through that membrane. Then the remaining molecules will be remained other on the other side only. So only one molecules of one gas will come to one side. And the same technique, diffusion, can be used to separate the gases in other way also. When two gases are passed through a test tube or any long tube, the gas with lower molecular weight will diffuse very fast and comes to the other end quickly. Whereas the gas with heavier molecular weight will move slowly and remains inside that only for certain time as it is moving very slowly. So based upon this property, gases can be separated by using the technique called diffusion. For example, the mixture of hydrogen and sulfur dioxide can be separated by diffusion. For example, it is given here two gases, hydrogen and sulfur dioxide. Out of these two, the gas hydrogen is lighter in weight because its molecular weight is 2. Very lighter weight, light gas. Lightest gas it is actually to say. Its molecular weight is 2. It is having lighter density. Whereas if you see sulfur dioxide, we know sulfur dioxide molecular weight is 64. It is much heavier gas. So if you take sulfur dioxide gas into a container, it can be poured like a liquid down. Of course, we cannot see that, but it will come down like a liquid down because it is a somewhat heavier gas. So these two gases mixture can be separated easily by diffusion process. When you pass these two gases to pass through a long tube, both two gases are left at the same time through one end. Then at the other end, immediately hydrogen gas can be collected easily as it is a lighter weight gas. It moves very faster. Okay, this is a diffusion process. Next, dissolution in suitable solvents. In this method of separation, difference in solubility of component gases in a solvent is used. Yes, the mixture of two gases can be separated by using solubility technique also. So when you pass this, suppose there are two gases mixture is there. If you pass that gases mixture through a liquid, one of those two gases is soluble into that liquid, the other one is won't be soluble, insoluble. Then that two gases can be separated by using the soluble technique. For example, mixture of nitrogen and ammonia can be separated by dissolving in water. So what happens here when you dissolve nitrogen and ammonia gaseous mixture into water? We know out of these two, ammonia is fairly soluble into water, whereas nitrogen won't be dissolved. Nitrogen is insoluble gas. So when you pass these two gases mixture, nitrogen will be dissolved into the water. Only nitrogen gas will be separated easily. So this technique is called solubility method. So if one of the two gases mixture is soluble into one of the liquids, then by passing through that liquid, that gas which is insoluble can be separated easily. Next technique, preferential liquefaction. In this method of separation, difference in liquefaction points of component gases is used. Liquefaction point means what? Liquefaction means conversion of gas into liquid. So generally, all the gases on cooling they convert it into liquid state. For example, if you take water vapor converts into liquid water at 100 degrees Celsius as it is its boiling point. The same will be its liquefaction point also. On cooling water vapor to 100 degrees Celsius and it below it starts converting into liquid form. That is called liquefaction or is also called condensation. Here the small difference between the condensation and liquefaction is condensation is conversion of a vapor into liquid state. Means actually it is a liquid, on heating it is converted into vapor form, again on cooling it starts converting into gas liquid form, that is called condensation. But actually some substances they exist in the gaseous form at normal temperatures, then by cooling them to below temperatures they will be converted into liquid form, that is called liquefaction. So in the condensation, the substance actually it will be in the liquid state at normal temperatures. But in the liquefaction, the actual state of the substance will be gaseous state. On cooling, it converts into liquid form. That process is called liquefaction. That is a slight difference between liquefaction and condensation. Okay, in condensation process, the original state of the substance will be liquid state, whereas in the liquefaction process, the original state of the component is gaseous state. But both are conversion of gas into liquid only. Okay, so in this liquefaction point, based upon the difference in the liquefaction point, also the gaseous mixtures can be separated. For example, a mixture of ammonia and hydrogen can be separated by this method. Yes, if you take the same mixture of ammonia and hydrogen gases, this if you cool it, ammonia will be liquefied very easily. Here, ammonia gets liquefied under high pressure and hydrogen gas is left behind. Yes, if you take the mixture of ammonia and hydrogen, on applying a little pressure and if you cool it, ammonia gas will be easily liquefied, whereas hydrogen still will be in the gaseous state only, so that that liquid can be separated from the gas very easily. Okay, this is called liquefaction process, preferential liquefaction, by cooling to a particular temperature. For example, if you take hydrogen itself, it has its melting or liquefaction point is at nearly 180 minus 190 degrees Celsius temperature. When it is cooled to the temperature only, it comes into liquid state. Whereas ammonia, it converts into liquid state at very near temperatures by applying pressure. By this, these two gases can be separated. Next, separation of liquid gas mixtures. So liquid gas mixtures can be separated by heating. In this method of separation, decrease in solubility of a gas with increase in temperature is used. Yes, here the technique used is on increasing temperature, the solubility of gases into liquids will be decreased. For example, when a solution containing a gas is subjected to sunlight, sunlight or heating below the boiling point of the liquid, the gas escapes out, leaving behind the liquid component. For example, separation of dissolved oxygen in water by heating it water. So what happens if we take a small quantity of water into a bowl? If we start heating it, you can observe some bubbles will be coming out from the water. That is because of the escaping of this oxygen gas dissolved in the water. Oxygen and carbon dioxide gases will be a small quantity, they will be dissolved in the water. So when you heat the liquid, then the dissolved gases will escape out. Okay, this is because the dissolution or solubility of gases into liquids decreases on increasing temperature. Okay, this is one technique. One more technique of separation of solid gas mixtures is liquid gas mixtures is lowering the pressure. In this method of separation, difference in solubility of gas in the liquid at different pressures is used. For example, soda water can be separated by this method. Here, when soda water bottle is opened, the pressure of the bottle decreases and carbon dioxide gas fizzes out of the bottle. Yes, we observe this often when we take some cool drink bottles. If we open the lid, immediately we observe some fizzing sound will be coming out from the liquid container, that soft drink container. This is because actually when the lid is closed, inside of the bottle, pressure will be a little higher. At that high pressure, more amount of gas will be dissolved. When you open the lid, pressure decreases inside, so that gas dissolved will escape out, because as pressure decreases, solubility of gases decreases. So gas will be escaped out on decreasing pressure. That means on opening the lid. That is why we observe this fizzing sound coming out from the soft drink bottles when you open the lid. Okay, it is one of the techniques operation. Thank you for watching our video. Please subscribe our YouTube channel Aims Today for latest updates on recorded videos. Thank you.